Okay, so this is part 2 to 4.7, reduction of constant coefficients. So what we're going to talk about today is what about the non-homogeneous differential equations. So here's one. So we do start off with solving YC, and that is our corresponding homogeneous equation. And we'll use the method that we used in the last video. We will use the Cauchy-Euler formula. So we set y equal to x to the r and take the first and second derivative to plug it into there. So the y double prime, the y prime right here, minus 3y, which is x to the r equals 0. Okay, so let's combine these. And this cannot be 0 because x is greater than 0. So we solve So my fundamental set is x to the minus r, x to the 3 halves, yc, okay, so we found our yc. Now for our yp. Yp, we can use undetermined coefficients. So the second is variation in parameters, and basically it's just the two methods we've learned on previous videos. And I'm gonna go ahead and work out undetermined coefficients here, and if you want to work out variation in parameters, you get the same thing for yp. You can also check it in my notes. So my first guess, since my g of x is x squared, if you remember, right here. My first guess is ax squared plus plus bx. Got to include all the derivatives in there, bx plus c. And we're going to compare it to yc. And here's our yc, our fundamental set. And x squared's not in there, so they are all 3 independent. Well, every term here is independent. We have a power of 2, 1, and 0, and negative 1 and 3 halves are not the same. They're independent. So therefore, that's our guess for y. So our y, my y prime, y double prime, and we'll plug this in to our original. So we have 2x squared y prime, which is 2a, plus x times y prime, 3 times y, and let's go ahead and equate coefficients. In front of my x squared, it's 1 over here. Oh, I could have just added that up. 4, 5, 6. Minus b equals 0. Minus 3c equals 0. So b equals 0. And c equals 0. So my yp, plugging it in, they're all 0 except for a. My solution, my general solution, my YC right here. Okay, we're going to learn a new method. It's called reduction to constant coefficients instead of the Cauchy-Euler. And we're going to do the same example above so that we know we get the same answer. So we're going to first, I want to remind you how to do derivatives with a parameter, okay? So y prime, which is dy dx, is dy dt times dt dx. And we don't need it here, but if you'll remember, we also had it stacked in Calc 2. So that's the same thing. And you can see the dt's cancel and you get dy dx. So our second derivative, this is basically the derivative of y prime with respect to x. It's the derivative of y prime. We can write it like that, same notation. And now we can utilize the top idea. So it's dy prime all over dt times dt over dx. So we have this and this. Okay, so here's our new method. Reduction. We're going to let x, so our substitution that we're going to use, equals e to the t. And basically, if I take the derivative with respect to t, dx dt, that is e to the t. And then let's say I wanted to find what if I needed dt dx? Whoops, dt dx. Well, it's just the reciprocal. That means it's going to be the reciprocal of this. Okay? So we're going to box that. And this is, again, contingent on this substitution. So we'll be using this substitution for our problem. Okay? So if that's going to be our substitution, what we're going to need to define is y prime and y double prime. Okay? So let's do it. And that's why we need these up here. Y prime, which is dy dx, which we can break it up since we're using t, dt times dt dx. And we see so you see how we needed that? This dt dx goes there, which is 1 over e to the t. And I think it looks prettier with the e to the t in front. And so let's write that out. And now let's do our second derivative. So it's the derivative of y prime, the derivative of the derivative, which is dy prime dx, which we can break it up. Whoops, we want it with t, of course. Break it up with dt in there. And see how we have dt dx again. But also, this is going to be, I'm going to put 1 over e to the t in the front. The derivative in terms of t of y prime, that's what, this is the same as that, just dropping it down. changing our notation. And we have what y prime is. Y prime is right here. So I replace it. And then we can use the product rule. So that's equal to, this stays in the front. Except I did forget chain rule. So I copy this times the derivative of the second one, which is the second derivative, times the derivative of 1 over e to the t, which is e to the minus t. So you have a minus because of the chain rule, and I copy that. And we can distribute this to make it look nicer. You add those. So that's what we can replace y double prime with. Again, you can memorize those or you can just go through the math. It doesn't matter. In one of my examples below, though, I will be doing a third order, which means we'll have to do the math ourselves again to find y to the third derivative. Okay, we're gonna, like I said, I was gonna do the same example. So we're going to use the original substitution. Remember, I reboxed it, this one. And we'll need this and this. And our second derivative. So 2x squared is e to the t squared, y prime, sitting right here, plus x. I replace x with e to the t times y prime. Y prime is this. Check that, yep. Minus 3 times y. Well, we don't actually have a y, so we just actually keep y there. See how we have y's in our formula? So that can just stay. There's no substitution there. But x squared, we will use this. So it's e to the t squared. Power to power, that is going to be e to the 2t for both of those. I'll just write that. And power to power is e to the 2t. So again, I kept the y. I kept the y. Because if you look, we do have the equation in terms of y's and t's. Okay, so that's the part you have to remember. So now let's simplify. Distribute this. Don't really need this parentheses. Ooh, it looks like it's going to cancel. That will cancel with this and that. Those cancel. See what's happening? We, one step. And if you want, you can go to y double prime minus, you can combine those, which is just minus 1 y prime. But you do have to remember it's in terms of t, it's dt. So constant coefficients. This is to solve our homogeneous. We'll plug those in. So not a coincidence, we got the same polynomial. This is a little bit different though. This is e to the minus t, because r is -1, and e to the 3/2 t, okay? So we can keep going now, find our yp. So we have our yc. So my yp, my guess, my first guess. Now this is e to the 2t, so it'll be a e to the 2t. And when we look at our homogeneous, or yc, 2t, -1t, and 3/2 t, they are all independent, so we don't have to worry about it. That's going to be my guess. So I kind of put a check mark there. That's my yp. I'm going to take my derivative of that, my second derivative, plug it in. To our original. So we can equate coefficients. 2 times y double prime. Combine those. We can combine these. Equate coefficients. That's a 1 in front of there. 3a equals 1. So my y? But if you remember, this was not in terms of t to start with. So we're going to use the original substitution, x equals e to the t, which basically I'm replacing it with natural log. Take a natural log of both sides. Natural log of x equals natural log of e to the t. So here we have t equals natural log of x. So we have to change it back to x's. You have to do the power rule. There was a 2 here. And then we get these cancel. And that was the same answer we got before. Just want to mention too, we could have gone a different way algebraically. So if we would rewrite this, probably easier. So we're writing this as power to power but I'm flip-flopping. I'm putting the t inside, the 2 outside. Power to power, you multiply. T times 2 is 2t. 3/2 times t is 3/2 t. That's minus t. And then you can see, then we can use x equals e to the t, and that just gets replaced. You can see it now. It becomes that. This becomes x, and so forth. Okay, ready for another example? Third order. So I opted just to do a homogeneous one here. And we are going to use reduction to constant coefficient. We're going to use, but clearly we'll have to find the third derivative in order to plug in. And before we can plug in all the x's for e to the t, we need to be able to find those 3. first let's take the derivative of both sides here with respect to t, and then flip it. So our first box that we're going to have, that we'll be using. So remember, this is the derivative of y prime, so we're replacing y prime. We'll take the derivative of that times dt dx, which was in our first box. So here we have to do the product rule. And I'm going to write this first, 1 over e to the t first. So it's 1 over e to the t times, copy that. I'm supposed to just copy this from here. Yes. Plus, I take the derivative of this, chain rule it, that becomes a minus. Times I copy that. It's probably actually nicer to distribute those out. Okay, kind of see a pattern? I'm going to guess it's 1 over e to the 3t. Because we are going to have to find that now. It's the derivative of my second derivative in terms of t, which is, now we're going to put in the t, dt. So this is 1 over e to the t, which I'm going to put first. And I'm going to take the derivative of y double prime, just rewriting that notation. Okay, so this is basically the derivative of the previous one. Okay, so let's do it. Just do it underneath. Derivative of that, this is e to the minus 2t, which is minus 2. That's the chain rule. And that stays the same. And then now we're going to take the derivative of that and copy that. And take the derivative of each of those, and that's just the third derivative. And this is the second derivative. Okay, so we just got to clean it up. Just distribute. Remember I told you it would be we'll factor those out with that. 2t plus t is 1 over e to the 3t. And then distribute that. There's nothing to distribute. We can actually, with those gone, this gone and this gone. So the squares is minus 3, and then it's 2 dy dt. Which fits our pattern. And so now let's plug this into our equation. And let's not forget our original x equals e to the t. Okay, let's substitute all this in there. X to the third will be e to the t to the 3 to the 3t. times my y triple prime. 3x squared is e to the 2t. Copy my y double prime. Continuing to the second line, plus 6 e to the t y prime minus 6y equals 0. Okay, let's simplify. These will cancel conveniently. These will cancel. And I'm also going to change notation. Use that notation. But it will be in terms of t now. Don't forget. Add your like terms. Be able to factor e to the rx from all of them, except it is t. You're supposed to remind me that. Synthetic division. Oh, look at that. Three distinct roots, pretty easy. So our YC. Yeah, this is, don't forget, we can still solve homogeneous equations. So my YC is my general solution because it's homogeneous. But of course we have to do our substitution. X equals e to the t, and remember the power to power rule. E to the t, that's c1x. That's c2x squared. Remember, because this is e to the 2 to the third x squared. Okay. That's it for the section.